those cancel. So this is going to be 2x plus 1 over square root of x times x plus x squared minus 2 square root of x.
Would be all over.
Oh yeah, put it all over x.
The second derivative, so it was 2x to the second, or sorry, the 2x, which came from the x squared, and then minus 2 stays the same. The only thing that we mess with is the square root of x. Is that right? And the 2 goes down still?
Yeah, so ignore that 2. So the square root of x is 1 over 2 square root of x.
Oh, I see.
And then the 2's cancel each other.
Okay.
If you left them both there, that'd be fine.
Yeah. Yes, yes. I thought I was doing the product rule.
I don't think we're.
And why did you get, on the first one, you got 2x plus?
Thank you.
Okay.
If you didn't cancel out the 2's, would that be bad?
Lazy, I didn't want to write them. So. Okay. Any questions there?
Now there is a trick that we can do on this that will make the derivative easier, a little bit quicker. And it's optional, you don't have to do it. But whenever we only have one term on the denominator like this, we can always split it up in the numerator. Okay, a fraction with 2 terms in the numerator can split up and each one gets its own copy of the denominator. So this is just a fraction rule. A plus b over c is a over c plus b over c.
Oh, so you just did 2x to the second, x to the second over x, which came from the bottom, and then same for the
Other.
the other one?
Yeah. And now if we simplify this, so x squared over x is just x. And this square root of x is x to the 1/2. So this whole thing is going to be x to the 1/2 minus 1, which is x to the negative 1/2. We haven't did, this is not derivatives yet, this is just algebra. X squared over x is just x. Square root of x over x is x to the negative 1/2.
Will there be any problems where we have to do this, and we just do that?
When we get into chapter 5, when we do antiderivatives, we do this backwards. You will have to do this in chapter 5.
That's the question I get there.
And now from here, we can take the derivative of this. Derivative of x is 1. Derivative of this is negative 2 times negative 1/2 x to the negative 1/2 minus 1, which is negative 1/2 minus 2 over 2 is negative 3 over 2. Okay. And that is acceptable answer too. But you don't have to do it that way if you don't want to. You could just do a quotient rule. For derivatives, it doesn't make much of a difference where this is probably just as much work as doing the quotient rule here. Although if you look at the answer is a lot cleaner than the answer here. And so as you get more comfortable with all of this, that's probably the better way of doing it, because normally if you're like writing a paper or something or doing some research or trying to communicate this to a coworker or something out of whatever your career is, you would probably want to simplify this, and that's going to be kind of messy. Easier to simplify it before we take the derivative than after we take the derivative. So. Any questions about this? This was perfectly fine for this thing, so. Okay, so. C, y equals e to the x sine x. What are we gonna do here? Just product rule. Okay. Derivative here is e to the x. What's the derivative of sine x?
Cosine x.
Cosine x. So you're going to get this. Okay, so we're going to get e to the x sine x plus e to the x cosine x. Okay. Any questions there? What do we have to do here?
Chain rule.
Is it a product rule or is this a chain rule?
Chain.
Chain rule. So be careful with sine, with any of the trig functions, and with natural log. This parentheses is not indicating multiplication. This is a function inside of the log function. So trig functions need angles. Log functions need, the term for this is called the argument of it. We don't usually call them angles for log functions, but it has to have something inside those parentheses for the log to even make sense. So this is natural log of this, not natural log times this. So how are we going to deal with this? So the derivative of natural log, derivative of natural log of x is what? Well, if for this one, just our basic formula is just going to be 1 over x.
Oh.
But we don't have an x, we have this extra junk. So what is this going to be?
It's just the same, right? 1 over all that.
1 over all of this. But anytime we have junk, what do we have to do after we're done with it? Multiply by the derivative of that junk, which is 2x.
So how do you know to use the chain rule?
Because we have
Instead of the jump?
that junk inside of the log function. So we have, whenever we have stuff like that in parentheses, and inside of something else, then it's going to be the chain.
If it's just like a number or X, we don't have to put the derivative of it. Well,
Right.
we do, but it comes to zero.
Right, then you just do the, if it's just an x, it would do this. If it's just a number, it would go to 0. Probably be a coefficient. Any questions there?
So all the time, if we have multiple terms in the natural log, we have to put the.
Right, or if the 10 wasn't even there, if it was just the x squared, we still have more than just the x.
We have,
So it's considered like to take the derivative if it's more than just X.
More than just a plain basic x. So here's a plain basic x, we just do our normal rule. Anything inside of here more than that, even if it's just the x squared, still more than just a plain x. So we have to do the chain rule on it.
and what would be the chain rule for that?
We would just do, when we did it, we would go, if it was just that, we'd go 1 over the junk, and then the derivative of it. So it doesn't matter what that junk is, it's just 1 over that junk, and then after you're done with that, you multiply by the derivative of the junk.
The derivative of the junk. So if that was,
No, go ahead.
if that was an x to the fourth, then it would just be 4 times x.
4x.
No, I mean for the times.
Right, if it was x to the
Oh,
fourth.
the cube, right.
Yeah.
It's a second, only takes 1, right.
And the reason we know to use that function is it has LN.
Natural one.
Okay.
Okay. Any questions here? Okay.
Really
We're gonna figure out how to.
Okay, so y equals 1 minus secant x over tangent x. Another thing about the derivatives, it's gonna go through our entire list and use all different types of functions. So now we're working on a trig function quotient rule here. And so it's gonna be applying product rule, quotient rule, chain rule, using all the various different types of functions that we have. Okay. So, does everybody see this as a quotient rule? Yep. Yeah, we could split this up into 2 separate ones, but there's not really any reason to do that. So 1 minus secant x, tangent x,
Do you remember all of them?
all the derivatives. Yeah, I write them on the board 30 times a semester for 15 years. Okay. Okay, so what's the derivative of 1 minus secant x? So the 1 goes away.
Right.
Negative secant x tangent x. And derivative of tangent x? Secant squared x.
Here, bro. Shit.
And this is the only forms that we're gonna have to do it right, because the secant squared x also means it's just in parentheses to the square,
Yeah.
right?
If you wrote it that way, in parentheses with squared, that would be good.
Okay.
Okay, so y prime, we're doing quotient rules, so we're gonna get this. So negative secant x, tangent x, tangent x, minus 1 minus secant x, secant squared x.
Did you, is it better to just put everything in parentheses?
Safer. In this case, these are the only parentheses that are required here. Because we have 2 terms, you have to put parentheses around it. These parentheses are all optional. Over tangent squared x.
And that could be a final answer.
That can be a final answer. I mean, we can, if you want to, you can tangent x times tangent x tangent squared. You could distribute this in and you get secant cubed, but you don't have to.
So the bottom one, that's what I'm saying, right? So I could take the square out and just put it in parentheses to the
Do it
center.
this way.
Same thing, right?
F of x, natural log of x, over x minus natural log of x. Okay, what are we gonna do here? Roll. Okay, so natural log of x, x minus natural log of x. Derivative here, 1 over x. Derivative here,
Negative 1 over.
what's that term?
Oh, 1 minus.
1 minus 1 over x.
Can we just leave it like that when we're putting it together?
Yeah. Okay, and so we're going to do this one. 1 over x, x minus natural log of x. Minus natural log of x. 1 minus 1 over x. All over x minus natural log of x squared. Not so bad. About 2/3 of the derivatives are going to be about this. About this complicated. It's just here's a product rule, here's a quotient rule, here's a chain.
We don't have find the epsilon and delta and all that.
No, there's no
That's
kind of meaning
complicated.
epsilon delta. It's just all this whole test is just all the derivative rules that we've been doing over the last month. Okay. Okay. G, I'm going to skip over G. This one, this type is not going to be on the exam. This is the one that has an x in the base and an x in the exponent. And that was the one where we had to take the log of both sides. There's not going to be anything on the test where you have to take the log of both sides. Okay. You probably won't ever see that in any of the classes you take. Moving forward. It's not gonna happen.
Can you say that again, please? So this
It,
is
this
not
has an
gonna
x, this one has an x in the base of that and in the exponent. So it's not multiplied, it's one is the base, one is the base, one is the exponent, so it's raised up there. That one you have to do the special trick where you take the log of both sides. Okay. Not gonna be on the exam, so I'm just gonna skip over this one. Okay. Now, this one absolutely, there's gonna be some exponentials on there. Now, this one is, the x is in the exponent, but it's not in the base. So we can do this one. So how do we, so here, this is y. Y equals e to the cosine of x squared plus 1.
What number is that? Is that sum 2?
Still number 2. How do we take the derivative of an exponential? First thing you always do is just copy it down the way it is. So y prime is e to the cosine of x squared plus 1. Is it the right base? Is it the base we like, or is it an alternative base? What's the base that we like?
When you bring it to the bottom?
Well, what's the, is this the easy formula, or do we have to do the, do we have to deal with something because of this? No. Anytime it's an E is our base. We like the base E. Base E is easy to work with. Any other base is harder to work with. If it was any other base, if say 3 to this power, then we'd have to do a natural log of 3. If it was 17 to that power, we'd have to throw in a natural log of 17. But because it's E, we can just move on to the last step, which is look at the exponent. Is our exponent just a plain x with nothing else? Or is it something more complicated?
Something more complicated.
This is definitely something more complicated, so we're going to have to take the derivative of that exponent and multiply it here. But if we're going to take the derivative of cosine of x squared plus 1, what rule do we have to use on this?
Chain rule.
This one's going to be the chain rule. What's the derivative of cosine?
Minus sine.
Negative negative sign of
Two X.
x squared plus 1. We're not ready for the inside yet. We're still working on the sign. Just copy the jump down. And now what do we do with the jump? Now we take the derivative of it. So this is going to be times negative sign x squared plus 1 times 2x.
Can you repeat that again? Because it's an E, so anytime it's an E to whatever, it's still the same,
Yeah.
right?
Yeah.
So
Or it doesn't even have to be necessarily e. It could be a 3 or a 7 or a 42. You always copy an exponential down. Whenever the x is in the exponent, you're just going to copy it down the way it is as your first step. Then we have to look at the pieces that aren't quite right. We would like it to be e to the x. In this case, the e is correct, so we don't have to worry about that step. The exponent is not, so we have to worry about this dealing with the exponent as multiplied by its derivative. So you always start with copying it down. Take the original one, copy it down, and then work with the pieces that are a little bit more complicated.
And you're copying it down what?
It's exponential. The x is in the exponent, copy it down. Yes? Yeah, there's another example coming up later that uses, like this next one has a base A instead of an E. I'll probably give you something that's, give you a number there instead of A, but yeah, it is the same.
So you applied the chain rule here.
And apply the chain rule. Actually, technically, we applied the chain rule twice, because this comes from the chain rule on that, but this comes from the chain rule on this, so we did it twice. Any questions there? We're starting to get down into the little bit trickier ones here, so. Okay, y equals a to the x squared minus 5x.
You just, plus a line, just to separate.
Just to separate them.
Is it the same thing as the previous one?
It is, but it's an A instead of an E, so we have to deal with that. Okay, so
Are you doing K?
we are doing. Oh, did I skip over? I skipped over. Oh, we'll come back to that one.
Yeah.
Okay, sorry. I skipped over one. Okay. So, what do we do with this one? Where do we notice the x's in this one? X is in the exponent, which means this is an exponential. We're going to copy it down. Okay? Times. Do we have the right base? We want it to be base E, but this is not base E. So how do we deal with that? Times natural log of A. Okay, so that deals with the base being wrong. What about the exponent?
So what's the difference between this one and that one? Why are we
It's an
doing
E
that?
instead, it's an A instead of an E.
Oh, I see.
Exponent. Is this the exponent we like, or is this something more complicated? We like it to just be X. This is definitely more complicated than just X. So we're gonna have to deal with that coming up next. So what are we gonna put here? The derivative of the exponent. 2x minus 5.
So we didn't have to do the chain rule because there's nothing, so the other one had cosine to it, attached to it, this one doesn't.
Right, yeah, this one, we didn't have to do an extra chain rule over here. So.
Okay, so what, you just did the derivative?
Mhm. this is the chain rule, from here to here is the chain rule, but this one, from here to here is the chain rule, but also from here to here is the second chain, so this one had two chains. But if you follow these steps for any exponential, the chain rule is included in those steps. Okay. Any questions here?
So when it's a different base other than E, we don't, you know, in the previous one, we have a parenthesis where we pretty much copy the junk. When it's not the E, then we're not able to do that.
I mean, we still copy it.
No, but like in the
And then-
second step.
The second step, we do the base, deal with the base, and then the third step, we deal with the exponent.
Okay.
Here, we copied it. Second step, we deal with the base, but the base is already correct, so we don't have to worry about it. And then the third step is this. Now, I put that in parentheses because it was messy.
Yeah.
This one doesn't, I mean, this one, I guess, needs parentheses too, because it's two terms. This one needed parentheses because of the minus there.
But there's no part where we gonna copy the junk.
No, the junk doesn't get copied. I mean, it does get copied here
Yeah, but that's.
as part of that, but that's just
Throw it in
removed.
the trunk.
Any questions about that?
Throw that junk in the trunk. We're just gonna throw that junk in the trunk.
Tangent inverse of 4x cubed minus 5x squared. Okay. Quick reminder, the derivative of tangent inverse is 1 over 1 plus x squared.
3, 2, 1.
Okay. So what are we gonna do here?
Now, is this a chain rule or a product rule?
So that's a good question. Is this a chain rule or is this a product rule?
Both?
Is this tangent inverse times this? Or is it tangent inverse of this?
It's times.
Tangent inverse of
product.
So is it trig function? Trig functions have to have an angle. What's the angle for tangent inverse here?
4x.
That is the angle. So if it was this, what's the angle for tangent inverse here? The x is the angle, that's just something else tacked onto the end of it. Here, tangent inverse has to have an angle. There's only one option for that angle, and that's that inside there. This is inside the tangent inverse function, it's not multiplying. This would be a product rule. This is going to be a chain rule. Does everybody see that? Okay, so how do we take the derivative of this? How do we use the chain rule? So this is the formula here. How do we modify that because we're doing chain rule? What's that?
Put the junk in the x.
Put the junk in place of the x. So we're gonna rewrite this exactly the way it is, except that x is gonna get replaced with the junk. So 1 over 1 plus what used to be x, but now is all of that junk squared. So
Right
this
down.
got replaced with this. Okay. But we're not done because we had junk. What do we have to do with the junk after we're done with it? Now we need to take the derivative. The derivative of this, now we need parentheses, we have two terms, so we need parentheses here. So this is going to be parentheses 12x squared minus 10.
Plug that into there.
happened to the second part again? Times 12?
Derivative of this, derivative of this.
And that's the final answer?
Yeah, that's our final. Okay. What type of problem is this? So options are product rule or chain rule here. Is that cosine multiplied by log, or is that cosine inside of log?
Inside log.
It's inside, because again, log has to have an angle or argument or something. Okay, so this is another chain rule. What do we do with log functions? So derivative of log base A is this.
So one over cosine x times natural log of A.
Okay, so this x there is getting replaced with that cosine x. But we're not done. What do we have left to do?
And a product,
The
Times
derivative of the cosine x, right?
derivative of the cosine, which is,
I'm gonna sign it.
So I have a question.
yes.
How are you able to tell whether it's
no worry.
inside? So can you write really quick what's not gonna be inside?
If it was a product rule instead?
Yeah.
Oops. Something has to be inside the log. If we give it something, then that's free to not be inside the log. But here, we didn't give it anything else. There's nothing else to be inside the log except for that.
So then the way we would solve that is by only product?
This would only be a product rule, yeah. Pretty straightforward product rule. This one is a chain rule. This is product. Let's chain. So recognize the difference here. This one is giving the log something before we get to the parentheses. This one is not.
So then we would just separate them, the top one. for
The top one, you would
just
just
separate
that
and do our.
and that and do your product rule. There's a few places in math where the notation is a little bit tough to get used to. And it just takes a little bit of practice in recognizing the difference between the two. Okay. Any questions here?
Yeah, how did you get, 1 over cosine x?
So we're taking our formula here
Uh-huh,
and we're replacing the x with the jump.
so cosine x is the same, the only thing, the derivative, then we do the afterwards.
Afterwards, yeah. Every time we do a chain rule problem, have your formula written out, and then whatever the junk is, just go through your formula, and anytime you see an x, just replace it with that. So in that case, we have an x in this position, just replace that x with a cosine x. So cosecant has to have an angle. What is there for it to be in its angle?